In this presentation, we have to talk about matrix representation of C2E group. The process of expressing the symmetrical operations of a geometrical structure in terms of respective matrices is called matrix representation. In the case of water molecule, the possible symmetric operations are E, the identity operation, C2, 180-degree rotation, sigma V, reflection through the horizontal plane, and sigma V dash, reflection through a vertical plane. Now replace all these operations in terms of few matrices. E is replaced by I3, that is unit matrix of order 3. Then C2 is replaced by this matrix. For that, just introduce a negative sign for the first element and the second element of the second row. This is a sigma V matrix. To construct the sigma V matrix, provide a negative sign for the second element of the second row. This is sigma V dash. For this, just to provide a negative sign for the first element of this matrix. This is the multiplication table of water molecule. For the construction of multiplication table, just write down the symmetrical operations in terms of a row and a column. Then E into E is E, E into C2 is C2, E into CV, sigma V is sigma V, E into sigma V dash is sigma V dash. C2 into E is C2, C2 into C2 is C2 square, C2 square is our identity element E. C2 into sigma V is sigma V dash. C2 into sigma V dash is sigma V. Then sigma V into E is sigma V. Sigma V into C2 is sigma V dash. Sigma V into sigma V is sigma V square, that is our identity element E. Sigma V into sigma V dash is our C2. Sigma V dash into E is sigma V dash. Sigma V dash into C2 is sigma V. Sigma V dash into sigma V is C2. Sigma V dash into sigma V dash is sigma V dash square, that is our identity element. We arrived all these elements in terms of symmetrical operations. We explained the same in detail in the previous lecture. Then using the value of C2 matrix and sigma V matrix, now we have to find out the value of C2 into sigma V. This is C2 matrix, this is sigma V matrix. If you make the product, you can get the new matrix, then that matrix is sigma V dash. Now verify the value of C2 into sigma V in the multiplication table. Actually, we constructed this multiplication table only through symmetrical operations. C2 into sigma V is our sigma V dash. Therefore, our matrix representation is absolutely correct. Furthermore, we have pointed out that C2 into C2 is equal to C2 square is equal to E. This means that every element has its own inverse. For C2, the inverse element is C2. That means C2 inverse equal to E. To prove this, go through this multiplication. This is the C2 matrix, this is C2 matrix, C2 into C2 is our I3. This is our identity element E. That's all about matrix representation.